In this video, we're going to do a couple of extra examples using synthetic division. So remember, synthetic division is a fast way to divide polynomials by divisors of the form x minus c. Okay, so this is always the form we're going to think of. You want to be careful. You can only use synthetic division when your coefficient in front of your x is 1 and the power of x is 1. So you can't do this for any powers higher than 1. So you want to make sure if you need to divide something with a power bigger than 1, you're going to have to use the long division method. Okay, so synthetic division is only for linear factors, so power 1. So let's try example B here. So we just want to use synthetic division to find the quotient and the remainder. Okay, now here we're dividing x to the 5 plus 5x to the 3 minus 10, so that polynomial, divided by x plus 1, which I gave you a hint in the last video to remember that x plus 1 is the same as x minus negative 1. Okay, so the reason why I want to change it is so that it fits this form. Okay, so the c value is actually minus 1. Okay, another thing you want to notice is this polynomial is missing powers of x. So it's actually x to the 5 plus 0x to the 4 plus 5x to the 3 plus 0x squared plus 0x minus 10. So when you're missing powers, you want to think of it as the coefficient is 0. That's why it's not there. So when you're entering it into your synthetic division table, you need to include those zeros. Okay, so our c value is minus 1. So we put that on the outside. And then I put in the coefficients in decreasing order. So in the write the powers in decreasing order. Okay, and then write the coefficients in that way. So our first coefficient is 1. And then we have a 0. And then a 5. And then 2 zeros. And then a minus 10. Okay, so the first thing we do is we bring this minus 1 down. Or sorry, the 1 down. Okay, and remember that this is our c value. Okay, it's minus 1. So when you're doing synthetic division, you always bring the first power down, and then to find the entries in this row here, you always take the c value and multiply it by the entry before that's down here. Okay, so we're going to take the negative 1 times the 1, that gives us negative 1 in that spot. Okay, and then you want to add column-wise, so add vertically. So 0 plus negative 1, that gives us negative 1. Okay, now we take this c value times our negative 1, and that gives us our spot here. So negative 1 times negative 1, well, that's positive 1. And then I add that to 5, I get a 6. Okay, then I do the negative 1, the c value, times the 6. That gives me negative 6. So I add that to 0, and that gives me a negative 6. Now I do negative 1 times negative 6. That gives me a positive 6. Add that to the 0 above, and I get a positive 6. Negative 1 times 6 is negative 6. Add that to the negative 10 above, and I get negative 16. Okay, so this last one is always the remainder. Okay, and these ones before is how we find the quotient. Okay, remember we started, the dividend was x to the 5. So the quotient is always 1 power less. So it's going to start at x to the 4. We have an x to the 3, x to the 2, x, and then the constant term. Okay, so that means that our quotient here is x to the 4 minus x to the 3 plus 6x squared minus 6x plus 6. And our remainder is negative 16. And if you want, you can check by multiplying it out. So you can use either this formula or this formula to make sure it all works. But I'll leave that for you. So we just needed to find the quotient and the remainder. Now in the next example, we want to check whether or not x minus a is a factor of f of x. So that means we want to know, is the remainder when we divide it 0? Okay, so that's what we want to do. So we're always looking for x minus 2. Is x minus 2 a factor of this polynomial here? Okay, so we just want to do division. So you can, or you can actually, I said, mentioned before, you could just plug it in and that will tell you if it's a factor as well. But if we do the synthetic division, then we have the factorization as well. So we want to divide 3x to the 4 minus 6x cubed plus 0x squared minus 5x plus 11 by x minus 2. So that means that my c value is 2 because it's already a minus. So I put the 2 in. I guess I always do it this way. But put the 2 in and then I write my coefficients. So I have a 3, a negative 6, a 0, a negative 5, and an 11. I bring down the 3. Okay, and 2 times 3 is 6. So when I add that to negative 6, I get a 0. 2 times 0 is 0. When I add that to 0, I get a 0. 2 times 0 is again 0. When I add that to negative 5, I get a negative 5. 2 times negative 5 is negative 10. When I add that to 11, I get 1. Okay, so this last here entry, this 1, this is the remainder. Okay, so the remainder equals 1. So since the remainder is not equal to 0, x minus 2 is not a factor of the polynomial 3x to the 4 minus 6x3 minus 5x plus 11. Okay, so in fact, it should be that 3x to the 4 minus 6x cubed minus 5x plus 11 is equal to x minus 2 times the quotient. So it's x to the 4, so this is x to the 3, x squared, x, and the constant. So it's going to be x minus 2 times 3x cubed minus 5 plus 1, so plus the remainder. So because there's a remainder here, it means that this thing did not divide evenly. Okay, so that's how we can use synthetic division to find the factorization and also to test if something is a factor or not.